Hello, this is Dr. Liu. In this video, I want to talk about how to use Python and the symbolic Python module to do matrix manipulations. And the example is on optics, matrix manipulation or matrix method for geometrical optics. So first, if you have installed Python on your own, you may want to install this module called SYMPY. I already did that, but I can still show you. Here is just typing pip install, and you can type a list of things you want to install. For example, that I can also add numerical Python module, and both have been already installed. So I hope they'll just tell me that well, these requirements have been satisfied. Otherwise, for you, there will be progress bars and some messages of this thing has been installed. And I normally use administrator's command prompt so that when you're installing this ensures that it's installed for everyone. So let's try that. And there we go. So we have these are already satisfied, symbolic Pi and numerical Python. There's also some dependent library that's or module that's required that's also satisfied. In your case, there will be progress bars after progress bars. And if you're using the apps anywhere, or you're on a campus computer and you run Python 3.9.x, these modules have been already installed. So okay, let's dismiss that and oops, just want to move this into the right half. Okay, so let's go through this. I never really went through this in good detail for you to replicate my work in optics lectures. So from here, this line here says from that module import everything. So everything in that module gets imported. And the next line is a way to print better matrices. Otherwise, the matrices don't print out nicely. So that is associated with the symbolic Python module. And the defs are my own functions that I defined, and I gave it a name. For example, get a translation matrix, get a refraction matrix, get these thin lens matrix, and calculate, get all the cardinal points. So these are my own definitions, my own functions, and then they're followed by a set of parentheses and also parameters that the function needs to run. For example, the translation matrix would need you to specify a length. And because I'm using symbolic Python, if you define any symbolic parameters such as length equals L, then they will get handled properly. So that is that. And then the colon indicates now we're starting a function. So now this indented content, these are all basically one-liners. The return function returns to the caller. So you want to get the matrix of translation matrix. So the return will be a translation matrix. The matrix reads the first row is 1L, the second row is 0, 1. So whatever L is assigned to by the caller, say L equals 5, and then this gets replaced by 5, and this whole matrix gets returned. So you don't have to memorize these matrix formulations, especially for this refraction matrix, and that's a little hard to remember. But you can always say, well, the left minus right over the right, and over the radius of curvature, then again the left over the right. So good for you if you can remember all of these, but you're not required. So that's what these functions are for, to keep those for you so you don't have to remember them, but it's good to have an idea what they look like, right? So these are all the matrices getting mirror and get that. So let's keep going down, and Python has this basically define as you use or use as you define. So this A did not exist, but once I use this matrix and assign a value to the A, when A appears on the left hand side and it has never existed before, it gets created, and the value of A gets assigned the value of this 0, 0. It's computer programming, so row and column indices start from 0. So 0th row, 0th column, that's the top left corner, is called A. and 0, 0, and 1. Well, row 0, column 1, that's the right columns, column 1, left columns, column 0. Right? So that's B. So these are defined, and then once these are defined, all of these cardinal points get defined according to these matrix elements. So these are all per textbook, assuming that you have the same medium on the left and on the right. You could make changes to that, but then you will actually let's see, would require these to be a little more accommodating, such as that is no longer a 1, it's going to be n left or n right, for example. Anyway, so keep going down past the assignment, list of assignments, and starting here we're printing out results. I remember I was printing these values out, and at the end I was putting a variable thickness into the matrix, and it complained it wasn't happy to print that variable length as a floating point. Of course, it has a symbol and it cannot be turned into a floating point. So instead of just printing these symbols like that, so they could be anything, could be numerical values, could have variables t and x in it. So print will be happy to print them out. So I print them each one on the line, and then I return all of these calculated results to the caller, so the caller can have a list and receive all the return values. So let's take a look at how I'm using the get thin lengths, that function there, get thin lengths. So here is the focal length. That's all is needed. So then we just we have a return matrix, so that will be returned to this L1, which was never there before. So L1 gets created, and its value gets assigned to this expression. So I have this thin length set up to be that focal length. This is one of the textbook examples. So that one is a translation. So the distance of translation is given. So the translation matrix is returned as T1, and as you see, T1 did not exist until this assignment. And then L2 is translating through the second thin length with a different focal length. Both are positive. And then my system matrix M is this the first thin length, then the distance between the two lenses, and then there's another thin length. So that's how this system matrix is constructed. And then you pass the system matrix to this this function, get cardinal, and then you receive all of these. Of course, these variables don't really exist in the main routine. They exist in this function, but not in the main routine. But now that you have a list, you are assigning these values over, and now they start to exist in the main routine. So you can pull the values. So let's go ahead and run it. And the first time you run something like this with the import, it'll be slow. So just go and run module right here. So this will take a moment. Okay, it went through, and you can see P, Q, R, S, and VW, and also the focal lengths and such. And we can actually try that. For example, if I just take that and I'll copy that. I'll replace that by a length L. But before I can do that, I need to declare that this L here is a variable. So var. Oh. Okay, so that's all it takes. If you have several variables, you can list them all in this single quotes with spaces in between them. So that would actually be, maybe I'll do that F1, F2. So I have both the focal length is variables. If I want to vary the focal length of one of the lenses, and I can do that. So over here, I'll put this hashtag here, so that is comments. So I'll paste over that value I deleted. So I'll save that and run it again. Okay, So it's a bit wider. Let's just widen out the display because now we have the L involved in some of the calculations. This is not that other example where we have this hemispherical thick lens that's facing the upstream with the hemispherical surface facing upstream. So you can see the L it just permeates into all of the calculations, while making things a little harder to read, especially they're interested in printing out so many digits. There's probably a way to control the amount of digits that are printed out, but I'm not interested in trying that. Okay, so there's this L is actually here, and you can also vary those focal lengths even. So if you do, for example, you instead of having this, so you put f1 here. Basically now this question is entirely analytical, right? So two different focal lengths in variables. I'll save that. And let's see how this goes. Okay. Oh, f1 is not defined. Probably I got the wrong definition. Let's see. f1, oh, here. The order matters. I'll put that in front. Probably should be a little further in front, but that's okay. So now I'll run that. So now you'll have been defined. Okay, so this is all entirely just analytical. Basically, it's kind of interesting. The matrix looks like this. I can even print out the matrix M. Okay, yeah, it's doing its best. So the M's components A, B, C, D's. It shows you how each component depends on the translation and also the focal length. It's interesting to use this method. So I think I've shown you enough about Python to get you started using it if you're interested, and I'm going to just maybe adjust them back after the video is over. So alright, thank you.